friends, welcome to NIKRA'S Expert Learning. In today's video, we are going to discuss what is a well foundation and basic components of well foundation, what are the forces that act on this, and the basic shapes of this well foundation. Coming to today's topic, well foundation provide a massive and solid foundation for heavy loads and are useful in situations where this load have to be transferred to a soil stratum. Whenever we have to transfer this load, the upcoming load, onto this soil stratum below this, we have to go for this well foundation. So this is just a diagrammatic representation of the well foundation. Coming to the top one, this is a girder, that is a beam-like structure, and it is having a bearing. To connect this girder to this well foundation, we are having this bearing, and this is a pier, that is a pillar-like structure to which we are having a gap, that is a top surface on which the bearing is provided. And here, coming to this, we are having, this is a top plug and this is the bottom plug, and the middle one is the sand filling, and this is the well staining. This is the main body of the well foundation, and in between we are having the sand filling, and at the sides you can see this is the vertical reinforcement. Whatever the vertical reinforcement is there, it is here, and to this we are having this horizontal reinforcements at this level, and this is a well curve having this cutting edge. I will be explaining you whenever explaining this definitions. So this is just a diagrammatic representation of well foundation. Coming to the first component, we have this well cap. See here, we are having this well cap. Right over the reinforcement, we are having this. So well cap, it is a RCC slab laid at the top of the well staining. It transmits the load of the superstructure to the staining. So whatever the load that is acting at the top, that is transferring it to the staining. So it is just an intermediate structure between the superstructure and the staining. Let us see what is staining over here. See, in the diagram, this is the staining part. So, coming to the definition, staining is the main body of the well which transfers load to the subsoil. It also acts as coffer dam during the sinking and provides weight for sinking. See, coffer dam is nothing but an interruption which resists the material backside of it. Okay, so this is staining. It is just the material which takes the load from this cap, and it will be transmitting it to the subsoil. Next we have curb. The lower wedge-shaped portion of the well staining is called the well curb. It facilitates the process of sinking. During the sinking, that is, this facilitates the process of sinking. So whatever the lower wedge-shaped portion, I will show you in diagram. See, this wedge-shaped portion we are terming it as well curb. Okay, this is the cutting edge. Cutting edge. The lowermost portion of the well curb is the cutting edge. It cuts into soil during sinking. So, as it is cutting the soil during the sinking process, we are terming this one as cutting edge. And sinking is again a different and important topic which gives a rise to other topics like tilt and shift. Even they are very important topics. I'll be making a separate video on that. And coming to the next component, we have bottom plug. See, as I have told you, this is the top plug and this is the bottom plug, and in between we are having sand filling. So after the well is sunk to required depth, the base of the well is plugged with concrete. It transmits the load to the subsoil. So whatever the load we are getting from the well cap, that is from the superstructure to well cap to the top plug, and top plug to bottom plug. So here we are plugging it with concrete. So whatever the main component that is plugged with the concrete, it is divided into two types. Like the top one is top plug and bottom one is the bottom plug. So it transmits the load to the subsoil. Next comes the dredge hole. The hole formed due to the excavation of soil is called the dredge hole. Top plug. A concrete plug covering the sand filling is usually constructed at the top, called top plug. So whatever the sand filling in between this top plug and bottom plug is there, we are terming it as sand filling. Okay, so that covering part of the sand filling, we are terming it as top plug. This is made up of concrete. It provides contact between well cap and sand filling and helps in transferring the load through the sand filling. See, whatever the load that is coming from superstructure, it is firstly resisted by the cap that transfers the load to the top plug, then the sand filling, and then comes the bottom plug. Okay, and after that it is generally transferred to the subsoil. Next, let us see what are the shapes of wells generally adopted. choice of the particular shape of well mainly depends upon base dimensions of pier or abutment. See, it is below the pier or abutment. Whatever the pillar is there, below that pillar we are having this foundation. So whatever the base dimensions, that is bottom dimensions of this pier or abutment are there, so depending upon that we will be choosing the shape of this well. Ease and cost of construction. Ease is the so whatever the degree of complexity we require and the cost of construction, whatever the we are ready to put into the construction, the amount, depending upon that we will be going for the shape. Next, tilt and shift during sinking and magnitude of forces to be resisted. So here the shape of well is selected such that it satisfies all the basic requirements. So it depends upon the base dimensions of pier abutment, the ease and construction cost, the cost that is incurred for the construction of this well, and tilt and shift, whatever the forces that are about to occur, it should be able to resist that forces. It should be able to resist the tilt and shift. Okay. So generally these are the shapes of the well foundation generally accepted. First comes the circular well, the circular one with the hollow space in between, which is filled again with the concrete, and this is a double D well. See, it is having a D section. So as it is having on both the sides, we are calling it as double D well. It is a dumbbell type, and here we are having twin well with circular dredge holes. So here we are not having this dumbbell shape, we are just having a straight lines. So again this is twin well with circular dredge holes. I have explained these dredge holes in the definitions also. This is a rectangular one. This is twin hexagonal, that is having 6 sides. Octagonal having 8 sides. So twin. In combination we are just constructing this. So these are the shapes generally adopted for the well foundation. Let us now see what are the forces that act on the well foundation. Well foundation is subjected to dead load and live load. In addition to this, it is also subjected to following forces. First one is wind force, forces due to water currents, forces due to breaking of bales, seismic forces, temperature and earth pressure. See, we know wind forces and water currents is nothing but the wave action of forces, and forces due to breaking of vehicles. Whatever the impact load is about to occur, that is from certain height or because of this breaking of vehicles, sudden break of vehicles, sudden application of break of vehicles will cause this force. And seismic forces, that is earthquake forces, which are unpredictable in nature. Temperature due to the rise in temperature or drop in temperature. Earth pressure. So these are the general forces that act on the well foundation. That is it for this video, guys. If you like this video, please like, share and comment to the channel, and don't forget to subscribe to my channel, guys. Thank you.